Good day. We've been doing some pH calculations in pOH, and so we've done some examples. This sheet is just tons of examples, and it will help you with the upcoming worksheets that are really quite straightforward. HCl is a strong acid, so it means if we know our concentration of acid, that's going to equal our H3O plus concentration. So we take our pH formula, we do our minus log of the concentration of H3O plus, and we get 2.00. If you know anything about math, you wouldn't need a calculator for that because this is 1 times 10 to the minus 2, and the log is just taking that 10 to the minus 2. It would come up with minus 2, and we flip the sign, so it becomes plus 2. Number 2, the exact same style question. We have a strong acid. We have the same formula. We plug in our number, but this time we'll let our calculator do the work, and we get 2.70. Notice both of these questions have the right sig figs because the significant digits are the right of the decimal point, and the number in front is really representing the power of 10. Now, way back in my day, we actually didn't have calculators like this, so we had to use tables of logarithms, which were just a delight. Number 3, what is the pH? And it's a 0.100 m sodium hydroxide, so it's going to be a strong base. So in this case, since we have the sodium hydroxide, it'll completely dissociate. So that's going to be our concentration of hydroxide. We're going to have a little extra work to do because we're going to first figure out our pOH and then convert that to pH. So here's our pOH formula, and boom, and again we didn't need a calculator for this, and this represents 3 sig figs. But we need to take our pOH and make it a pH, and we have to remember to do that we take 14 and subtract our pOH, and we get 13.00, and we've chopped to the nearest hundredth, thank that 14.00. Now we're into another solution. We're going to treat this like it's a strong base, and unlike acids, we're going to assume that when this dissociated, it did so completely, and every time one unit of these dissociate, it makes twice as much hydroxide. So what we had to do, the trick here, we had to double that number to 0.000600. So that's why we've doubled it, because of that subscript 2. We get our pOH, and we do the 14.00, and we minus 3.222, and we get 10.78. If you're hearing a strange noise in the background, my dog is chewing his nails. She's just a delight. What is the H3O plus of a solution that has a pH of 4.25? So now we're going the other way. We're starting with pH and we're going to H3O plus, so we have to use that anti-log or inverse log. So 4.25 becomes minus 4.25. We anti-log it and we get 5.6 times 10 to the minus 5. The 4.25 had 2 sig figs, so we have 2 sig figs here. 6. Now we have this pH, very high pH. We do the exact same steps, and we see we end up with a very small concentration of H3O plus. Not surprising when our pH is so basic. And we have one more example. So we're starting with pH, and we're trying to get to OH minus. We could do it in 2 ways using our little roadmap, and I think I've chosen the easier way to do it. So we're going to flip our pH to a pOH. 14.00 minus the pH gives us our 11.04, sig figs and all that. And now we're ready to anti-log the minus 11.04. And we get 9.1 times 10 minus 12 molarity. And that makes a lot of sense because we had a low pH. We can't have a lot of hydroxide there. So use these examples as a guide as you proceed through the next couple of worksheets.